Very good afternoon friends, and in this video we are taking another standard forms of the integration. In the previous video we just discussed about the various other forms of the integration. Now our focus is on how to find the integrals of the form sine cube x and cos 4x dx. Means the power on the sine is odd and the power on the cos is even. In this condition, the better is keep one sign out of this sin x and then other remaining signs as it is. Like sine cube x, we write it as sin x and sin square x, and then cos to the power 4x dx. Now you know that the sin square x can be converted into the cos square x, so you just write sin x, and at the place of the sin square x you write 1 minus cos square x and cos to the power 4 x dx. Now you just substitute, let cos x is t, let cos x is theta, so minus sin x dx is d theta, so you'll get minus this sin x and the dx will become d theta, and this is 1 minus theta square and theta to the power 4. If I compensate this minus sign here, then this will become theta square minus 1 multiplied with theta to the power 4. This will become theta to the power 6 minus theta to the power 4 d theta. Now on integration we will find theta to the power 7 over 7 minus theta to the power 5 over 5 plus c constant of integration. And now in this final answer, just to substitute the value of theta, which is cos x, so this becomes cos to the power 7x over 7 minus cos to the power 5x over 5 plus c. Same way, if it had been odd, even, and this one odd, then you have to do the same way, but the form will take another drastic turn. Now let me clear the screen and then I solve that one. So if I make this one as 4 and this one as 5, then what will happen? Then you can write it as sine to the power 4x cos to the power 4x and cos x. So what we do that, we just assume this cos x as t, this is dx, so let cos x as t, so it's differentiation of cos x is minus sin x and dt, so this is minus sin x and dt, so this term will become this sine to the power 4, will write it as sine square whole square, sine square x whole square x is sine to the power 4, and the sine square x I can write it as 1 minus cos square x, 1 minus cos square x whole square, and then cos to the power 4x and then cos x dx. So here I think I have made a mistake. I should have taken, I have cos x dx, so I should have taken sin x as dx, my bad. So this, let sin x as t, then you get cos x dx as dt. So this cos x dx can be replaced as dt, and this sin x, since I am assuming, so I need to protect this sin square x as it is, sine to the power 4x, and at the place of this cos to the power 4x we'll write 1 minus sine square x whole square. Now everything is in perfect order. Now here at the place of sine x you write t, so t to the power 4 1 minus t square whole square, and this will become just dt, because cos x dx is just dt. So cos x dx is just dt. Now this So now this you see that the t to the power 4 as it is. Now you expand 1 minus t square, that is 1 minus 2t square plus t to the power 4 multiplied with dt, and this gives you t to the power 4 minus 2 t to the power 6 plus t to the power 8 dt. And if I find the integration of these terms, then I'll have t to the power 5 is t to the power 5 over 5 minus 2 t to the power 7 over 7 plus t to the power 9 over 9 plus c. So this t is sine t, so it's 1 by 5 sine to the power 5t minus 2 over 7 sine to the power 7, sorry, this would be x, 7x plus 1 by 9 sine to the power 9x plus c. This is how this kind of question is solved. Now I take one more form, and there how can you find the integrals of the form sine to the power 4x or cos to the power 4x. Both can be solved in the same fashion. So let me solve them. So cos to the power 4x dx. The important formula here you have, that this I'm discussing the formulas, because sometimes the formulas through these videos, whenever time and again, whenever we find the opportunity, we'll just try to derive some formulas also, so that you can have the proper revision. So you know that cos A plus B is cos A cos B minus sin A sin B. This is the formula for multiple angles. Now if you replace A as B or B as A, so let's see that B is equal to A equal to x. So we'll have cos 2x as cos x cos x, that is cos square x minus sin square x. If you express this cos square x in the form of sin square x, you will have 1 minus 2 sin square x. Otherwise, if you write sin square x as in terms of cos square x, the whole expression will become 2 cos square x minus 1. So here if I just transfer this on this side and this on this side, so what I get, that 2 sin square x is 1 minus cos 2x, and 2 cos square x as 1 plus cos 2x. So we will be using the very same formula here. Now we have cos to the power 4x. So let me write this part here. So I is cos to the power 4x dx. This I can write as cos square x whole square dx. Now here you see that the cos square x is 1 plus cos 2x over 2. So what we'll do, that we'll write this as 1 plus cos 2x over 2 whole square dx, and this will become 1 over 4. Since I write this 1 by 4 outside, it will be much more easier. 1 by 4. Then we have 1 plus cos square 2x plus 2 cos 2x dx. These are the formulas. So there should be a separator. Now, so here you see that we have 1 by 4 integration of 1 dx plus 1 by 4 integration of cos square 2x dx plus 2 by 4 integration of cos 2x dx. First term, this one is integrable, this one is integrable, this one you cannot integrate, because it is just very much like this cos square 2x. So the cos square 2x can be written as either at the place of x, if I write 2x, this will become 4x. So what I'll have, that, let me use the red pen. So 2 cos square 2x is 1 plus cos 4x. So at the place of cos square 2x, we can write 1 plus cos 4x over 2. So this becomes 1 by 4 integration 1 plus cos 4x by 2 dx plus this 2 by 4 is just 1 by 2 integration cos 2x dx, and this one is 1 by 4 1 dx. So now here if I just try to find out this summation, so I have integration 1 dx here. This 1 by 4 times 1 by 2 will also be 1. So 1 by 4 into 1 by 2 is 1 by 8. 1 by 8 plus 1 by 4, that is 2 by 8, and total can be written as 3 by 8. So this is 3 by 8 integration 1 dx plus this is 1 by 8 integration of cos 4x dx plus integration of cos 2x, and this is half times, so this is half. So now I write the answer for this one. For this, let me clear this part, we don't need right now. So I write, and this value of integrations I write directly here. So this I is, so integration by 3 by 8 1, this is 3 by 8x, so 3 by 8x plus 1 by 8 integration of cos 4x is sin 4x by 4, sin 4x by 4, and then plus 1 by 8 is there, and 1 by 2 integration of cos 2x, this is 1 by 2 sin 2x by 2 plus c, which can be written as final answer. This is 3 by 8 plus 1 over 32 sin 4x plus 1 by 4 sin 2x. This is the value of this integration. Same way, sin to the power 4x or cos to the power 8x or cos to the power 12x, all those can be integrable into the very same way. They all can be integrated in this very same way, and that is how this kind of integration is achieved. So now I will go for other forms, and that will do in the next video. So in this video you have learned how to find the integrals of the sin to the power 4x, sin to the power odd, and the cos to the power even kind of expressions. And in the previous video you just see we have also learned how to integrate some other trigonometrical forms. Thank you very much. Just subscribe to our channel and keep practicing with us.